Hello friends, welcome once again to my channel. Today I'm going to start up this topic, which is differential equations. Okay, for you to do so well in differential equation, you must have a great mastery of the topic differentiation and integration calculus. You should have a very great mastery of these topics, differentiation and integration. It will help you so much to understand actually what we meant by this differential equation. So I encourage you to go and read up your calculus, differentiation and integration before you come into this differential equation for proper understanding. So look at what I have here on the board. I say that a differential equation is just a relationship between an independent variable x, a dependent variable y, and one or more derivatives of y with respect to x. So a differential equation must contain one, a dependent variable. Okay, it will also contain an independent variable, then a derivative, one or more derivatives of y with respect to x. And these are the examples of differential equations we have, which I've carefully written on the board for you. You can see the first one, it contains x, it contains y, and also a derivative of y with respect to x. Once you see an equation like this, you should know that that equation is a differential equation. And that is why I told you that a differential equation is just a kind of equation or a relationship that exists between a dependent variable y, an independent variable x, and one or more derivatives of y with respect to x. You can take a look at the second example I have here. You can see x and y here. You can see a derivative of y with respect to x also. So it is a differential equation. Look at the third one. You can still see a derivative of y with respect to x. Okay, you can see the letters x and y. Then in the fourth one, you can still see the same thing that it applies there. So for you to say that an equation is a differential equation, that equation must contain a dependent variable, an independent variable, then one or more of a derivative of y with respect to x. That is only when you can say that an equation is a differential equation. Okay, now having learned the meaning of a differential equation and the examples, there is what we call the order of a differential equation, because a differential equation can have so many orders. Look at the first example here. We can see that we only differentiated y with respect to x only one time. That is, the power here is 1. So this is said to be in the first order. This is said to be in the first order. But this one, you can see we had a second derivative of y with respect to x. Okay, so this is in the second order, because the highest power of derivative is 2. So the power of the derivative will tell you the order that differential equation is in. In the third one, now please, there is something I want you to understand here. You can see that in the third one, we have the first derivative and also a third derivative. Some persons might be confused here. They will be saying that this is both a first order and a third order. No, it is wrong. This is only a third order because you only concentrate on the highest degree, the highest power. So since the highest power of the derivative here is just the third, we can say that the order of this particular differential equation is the third order. So this is the third order. This one also, you can have the first order and the second order there, but you only concentrate on the highest degree. Okay, so the highest order here is just second order. So you can see that so many differential equation can have a lot of orders depending on the highest power of the derivative. Once more, a differential equation is just a relationship that exists between a dependent variable y, an independent variable x, then one or more of the derivative of y with respect to x. That is only when you say that an equation is a differential equation. So having learned the meaning of a differential equation, I want us to go straight forward into how to form a differential equation. So in the first question here, we want to see how we can form a differential equation. So this kind of equation is given to us and we are asked to form a differential equation from this given equation. To form a differential equation from any equation, you must make sure that the arbitrary constants are removed. Look at what I mean by the arbitrary constant, this a and b. Once this a and b ceases to be part of this given equation, it means that you formed a differential equation. So in this first equation, where we have y is equal to a sine x plus b cos x, let us take the derivative of this particular function and see what it will give us. Now when I take dy over dx, when I differentiate sine x from the standard derivative, you should know that the derivative of sine x will give us cos x. So I will have a cos x. Okay, and when I differentiate cos x, it will give me minus sine x. Okay, the derivative of sine x is cos x, while the derivative of cos x is minus sine x. Remember, you still put your constant. Okay, now if I am to take a second derivative of this given function, that is the squared y over the x squared, let's see what it will give us. If I differentiate cos x, I will get minus sine x, so I'll have it as minus a sine x. If I differentiate sine x, it will give me cos x. So this is still minus b cos x. You can see that at the first derivative, we couldn't get something that is meaningful because there is no relationship that exists between this given derivative here and the original question given to us. But when we took the second derivative, we see that this particular derivative and the original equation, they are almost the same thing. The difference is that when I multiply this particular equation by -1, it will give me this. Because when I times this by -1, I will get this. When I times this by -1, I will get this. That is just what it will give us. Okay, and so you see that this particular function and this function are the same thing. The difference is that the negative of this one will give us this one. Therefore, you are not wrong if you write that the squared y over the x squared is the same as negative y, because this thing as a whole, this function as a whole, is giving us a y. Hence, you can say that the squared y over the x squared is negative y, because when I multiply y by -1, I will get this thing back. So now you've seen how I form this differential equation, because there is no more presence of a and b. Whenever you remove a and b, the arbitrary constants, from a given equation, you form differential equation. So to form a differential equation, you need to do away with the arbitrary constants. That gives you a differential equation. For instance, now if I still want to work on this negative can come over, it becomes positive. Hence, I can write that the squared y over the x squared plus y equals 0. This is a typical example of a differential equation with the order 2. The order here is 2. So let's take another one. The second one, we will have y is equal to x plus a over x. What we need is to do away with this particular a. Once we are able to do away with a, we have formed the differential equation. So now, for example, let us take dy dx and see what it will give us. But before the dy dx, let's arrange this properly. This can be seen as y equals x plus a times 1 over x. Okay, because a times 1 will give us a over x. So this can be seen as x plus ax negative 1, because 1 over x from the laws of indices implies x power of -1. So we've seen that our y is just x plus a x minus 1. This is the value of our y. Now if I take dy dx, dy over dx, when I differentiate x, it will give me 1. If I differentiate this, the power comes to the back and the power is -1. So I'll have minus a x power of -1 minus 1. Remember, you subtract 1 from the power. That is why I told you to go and refresh your mind on the basics of integration and differentiation. So at the end of the day, we can see that our dy over the x is the same as 1 minus a x power of -2. Okay, and if I want to write it properly, I can still say that dy over dx equals 1 minus a over x squared. Please, this and this are the same thing, because since the power is negative, from the laws of indices, you can write it here like this. This is now our dy dx. But there is still presence of this particular a here. Hence, from the original equation, let me try making a subject of the formula and see if I can plug it in here. So from here, let the x come here, it will be positive, negative. So I have y minus x equals a over x. I brought this x here, so it turns to negative, so remaining a over x. So if I cross multiply now, I will make a subject. A times 1 will give me a equals, this x is multiplying y minus x, so I have y minus x. Okay, this is now the value of a. So coming here, wherever I see a, I will now put x into y minus x. So I will plug it in here. I will now have that my dy dx will now be 1 minus, seeing a, I'll put in x into y minus x all over x squared. I'll clean up here for continuation. Okay, so from here we continue. Dy over dx will now give us, this x is squared, cancel itself, we'll have x, it cancels out this x. So we'll have dy dx is now 1 minus y minus x all over x. Okay, this can be seen as 1 over 1. Then you find LCM. The LCM of this is x. X divided by 1 is x. X times 1 is x minus, this divided this is 1. So we have 1 multiplying y minus x. Remember, everything equals dy over dx. Okay, so we open the bracket. We shall have that dy dx is the same as x minus 1 times y is minus y. Minus minus turns to plus x all over x. This is the same as x plus x will give us 2x minus y all over x. Okay, here. Hence, dy over dx is now 2x minus y all over x. Okay, this is okay, but if you wish to make it more better, if you want to make it to be okay very well, you can cross multiply so that this x will multiply this. So if I cross multiply, I'll have it as x dy dx equals 2x minus y. So you can see that when x times this, I have x dy dx equals this 2x minus y. So this is now a differential equation because I have removed the arbitrary constant, and